Hi everyone, my name is Miss Janse and I'm really excited to learn natural sciences with you today. Before we begin, I would love for us to take a moment just to think about how we are feeling. Are you in a good place and you can focus, or is something bothering you a little bit? Or is there something that's really getting in the way and that's going to make it harder for you to learn? Wherever you are on this continuum, I want you to take a deep breath in and then out and get yourself ready for learning. Make sure you have your natural sciences textbook, something to write on and something to write with, and then you're going to have a great time. Let's begin. Today we're going to be looking at methods of physical separation. So, answer this. Which of these is your favorite drink? Now, think about how you make Oros at home, or how you make Milo at home. And how does the factory make Coca-Cola? There are all sorts of different ingredients put together to make a mixture. Yep, that's right. These drinks are all examples of mixtures. Bet you didn't think about that. Wow. Can you remember from grade 6 what a mixture is? A mixture is made up of two or more different substances. A mixture can contain solids, liquids, and/or gases. And finally, a mixture can be separated using physical methods. Can you think of more examples of mixtures? Look around you. Think about what you eat and drink. What kind of mixtures are out there? Pause the video and take a few minutes to make a list of 5 mixtures. Once you've done that, press play. Welcome back. You've got a list of 5 different mixtures, and now I want you to look at those mixtures and think about what different types of mixtures did you write down. Remember that a mixture can be made up of a solid and a solid and a liquid and a gas, a liquid and a liquid, or a gas and a gas. These are different types of mixtures. So, for example, what types of mixtures are these? If you look at a bowl of fruit salad, which is made up of all different types of fruit, all those fruits are solid, and so it's a mixture of a solid and solids. What about a cup of tea? It's made up of water, tea leaves, milk, and sugar, and so that is an example of a liquid and a solid, a whole bunch of liquids and solids together. What about smoke? What is smoke made of? Smoke is a mixture made up of solid, soot, and air. So soot is a solid and air is a gas. So this is a mixture of a solid and a gas. Then we have air. What is air? Well, it's made up of nitrogen, oxygen, argon, and carbon dioxide, and those are all gases. You guessed it. So this is an example of gas and gas. And then, this is a weird example, but these liquids all mixed together, once they settle, they form those different layers. And what's exciting about them is that they are all liquids. So this is an example of a liquid and a liquid, just like your Oros was an example of a liquid and a liquid. Now what I want you to do is to pause the video. Look at your list of 5 mixtures that you wrote down earlier, and next to each example, write down what type of mixture is it. Is it a solid and a liquid, or a liquid and a gas? What type is it? Write that down. Once you're done, come back and unpause the video. Well, now that you've got your list sorted out, I want you to think about the next thing. And this is about separating mixtures. If we took all those different examples, how could we separate those mixtures into separate parts? Well, If we wanted to separate the fruits in the fruit salad, how would we do that? Or if we wanted to separate the sugar from the tea, how could we do that? This is the exciting part. I want you to pause the video and scan pages 82, 84, 86, and 97 to figure out what are the names of 7 different ways that you can separate mixtures. Once you've done that, press play. Okay, so you've just used your textbook to go and discover 7 different ways to separate mixtures. Let's have a look what you found. Hand sorting, filtration, and sieving. Magnetic separation and evaporation. Distillation and chromatography. What we'll do next is we'll dive deep into each one of those different mixtures to find out more about how they work. So, we're going to pause the video. You are going to carefully read page 82 of your textbook. Once you've learned about hand sorting, sieving, and filtration, you're going to write down 1 or 2 sentences to explain each of these different mixtures, methods of separating mixtures. And then once you've written those down, you will press play. Now let's compare what you wrote. What did you write for hand sorting? Is it similar to mine? So hand sorting is when you separate solids by hand, when they're easy to separate. So for example, if you were given a basket of fruit and you could take your hands and physically separate the oranges from the apples, you could even separate the red apples from the green apples. That's called hand sorting. What about sieving? You use sieving when some of the particles are small and small enough to filter through a sieve, whilst other particles are too big to filter through. So in this picture, you'll see that they are sieving sand, and they are separating the small sand particles from the leaves and the twigs, which are too big to fall through the sieve. What about filtration? Filtration is when the particles in a mixture are too small to be separated by a hand or by separating using a sieve. And also often filtration is used when one substance is liquid and the other is solid, or one substance is solid and the other is gas. So then we use filtration. So in the first example, in the middle of the page, you'll see that muddy water is being filtered to get clear water. You have a beaker, you have a funnel, and you have some filtration paper, and you pour the muddy water into the filtration paper. And what happens is the filtration paper captures the big soil particles, so the muddy soil stays in the paper, but what runs through is the water. And so you started with muddy water and you end up with clean water. And then the other example is a firefighter wearing a mask. When firefighters are busy putting out fires, there's a lot of smoke. And so smoke, remember from the earlier example, is when there is solid soot particles mixed with the air. So what the mask does is it filters the air. So it allows only the air to go through, but it doesn't allow those solid particles to go through. And that way, firefighters are protected from breathing in harmful substances. So what I want you to do now is I want you to take what you've just learned. We're going to elaborate a little bit on what you've learned. Take what you've just learned, as well as the information in the case study that you're about to read, and then answer the questions. So, you are going to pause the video. You're going to read the case study on page 83 of your textbook, and then answer the questions 1, 2, and 3 about how a wetland acts as a natural filter. All right, you've just answered those questions, and now you're going to get straight back into finding out more about mixtures, ways of separating mixtures. You're going to turn to page 84 of your textbook and you're going to write down 2 sentences each explaining magnetic separation and then evaporation. Once you've done, you know what to do. Press play. So let's compare what you wrote to what I've got. Here we have magnetic separation. And this is used when you've got different particles in a mixture with one part of the mixture being magnetic and the other not. So I'm going to show you this video.
Alright, so another technique that you could use to separate mixtures is by using the physical property of magnetism. So what we have in here is a mixture of sand and iron filings. And if I want to separate the two, I could use the idea that the iron filings are going to be magnetic. So we're going to put this piece of plastic over top, and if I run my magnet through the sand, we can separate the iron filings from the sand due to magnetism.
Right. So that is a great example of magnetic separation. Now, let's look at the other method of separation that you just wrote about. You looked at evaporation, and that is when you use heat to separate a solid from a liquid. So, if you have, for example, sea water, and you want to get salt from the seawater, what you do is you use either sunlight or some other kind of heat to evaporate the water, and then you will be left with the salt. So let's look at that, what that would look like in the lab.
Hey viewers, no lines on chemistry here. Today we are going through the separation technique evaporation to dryness. We will need a tripod stand, an evaporating dish, a wire gauze, a Bunsen burner, and a glass stirring rod. For this experiment, we will be demonstrating evaporation to dryness using a salt solution. As we already have a solution of salt and water, we just need to stir it to dissolve all the salt. As you can see, all the salt has been dissolved. Now it's time to pour the solution into the evaporating dish for evaporation. After pouring the solution into the evaporating dish, place the evaporating dish onto the tripod stand with the wire gauze steadily. Here is the view of the evaporating dish from the top. Now we'll light up the Bunsen burner. Make sure the air hole is closed before this. Next, carefully place the tripod stand over the Bunsen burner. Lastly, you may open the air hole to enhance the flame. The last part, waiting. As you can see, all the water has evaporated, leaving the salt residue behind. This is how you separate a soluble solid from a solvent using evaporation to dryness.
Alright, so there you saw what happened. You had salt water, and you separated the salt from the water by using heat. So what I want us to do now is I want us to elaborate on the things that you've just learned. You're going to use what you've just learned as well as information you're about to read in the case study to answer a few questions. So pause the video and read the case study on page 85 of your textbook. You're going to be reading about salt mines and how salt mines are basically ways to create or produce salt by evaporating water. So you will answer questions 4, 8, 10, and 11. And once you've answered those questions, you will press play to continue with your lesson. You've just answered questions about salt mines, but you still have to learn about distillation. So I want you to pause the video here, go to page 86 of your textbook, write down 2 sentences about what distillation is, and then you know what to do. Press the video to continue with the lesson. So let's have a look and see if what you've written is similar to mine. So distillation is the separation of one substance from another by evaporation and condensation. So in the earlier example, we looked at evaporation and we saw if we took salt water, we could get salt if we heated the water, the salt water solution, got rid of the water, and then we would be left with the salt. But now, if you think about what if I want to capture the water and I want to capture the salt? What method of separating mixtures could we use then? Well, this is where distillation comes in. It's perfect for this because it allows you to capture both elements.
Distillation is a method of obtaining pure liquid from a solution. In this process, the solution is heated so that the liquid evaporates. Let's understand this with an experiment. Take some salt water in a retort and heat the retort till the steam comes out of it. We will see the steam getting collected inside the beaker in the form of droplets of water. The steam condenses and reaches the beaker, and the salt left behind in the retort. This method of separation of soluble solids from liquids is called distillation.
So, you've just looked at distillation, and now I want you to pause the video because there's one more method of separating mixtures that you need to learn about. This is what you'll find on page 97, and it's called chromatography. Again, write down 2 sentences explaining chromatography and then press play when you're ready to begin. All right, so you have found in your textbook what chromatography is, and now I want you to compare your answers to mine. Chromatography is used to separate colored substances into individual pigments. So, most inks are a mixture of different pigments blended together to give them the right color. If you take a highlighter as an example, it might look like this is a red highlighter, but if you were to use chromatography, you would find out exactly what colors are in here to make up this red color. So, when a mixture contains colorful compounds, it's possible to separate those components into different components using chromatography. So, this example over here, you can see that a sign has been rained on, and so no longer can you see what pictures or words were drawn on the sign because the colors were separated into all the different pigment components. Let's have a look at chromatography by looking at these videos. They are such exciting ways to
This video shows an example
mixtures.
of a chromatography experiment. The goal of the experiment is to separate the different pigments of ink which are present in a wet erase marker, which we'll see right here. So a vis-a-vis marker is wet erase, which means that the pigments are water soluble. We'll start our experiment by drawing a line with the marker on the chromatography paper. Then what we want to do is insert that chromatography paper into a beaker with a small volume of water in it. We can see that the water will start to rise up the chromatography paper because of capillary action. You'll note this happening very quickly because this is 16 times speed playback. We can see that the ink, which originally looked black, is starting to separate into different colors. This is because the different pigments have different properties. Some of them are heavier, some are lighter, some are more soluble in water, some are less. Because of these differing properties, all of the different colors are going to travel at different speeds. And by the completion of our experiment, we should see some very nice separation of the different pigment colors. Now, to do analysis of our results, what we're going to want to do is to measure the distance traveled by each pigment. Let's pause here for a moment. So I want to measure the maximum distance traveled.
So basically what this video has showed us is that even in a black Koki, you might think that the color in here is black, but in fact, all the different colors make up the black color, as you can see in the video. So once you use chromatography, you separate that black mixture and you find that there's yellow, there's red, there's purple, and that's very exciting to know that there's so many different colors within this one little Koki. I would like you to look at this video. It's also explaining chromatography, but it's just taking things a step further.
In this video, let us look at how we can separate the inks in different colored markers by using chromatography.
So this time around, instead of just looking at one Koki, we're going to be looking at different Kokis, and you will see what happens by watching the video.
Using a filter paper, we first draw a start line about 1.5 centimeters from the base using a pencil. Next, we apply small but concentrated spots of our samples on the piece of chromatography paper. This is important to ensure that there is enough sample as the individual components will be diluted when they move along the paper. If the sample spots are too large, it will be difficult to distinguish the individual spots on the chromatogram. The spot is made as small as possible so as to prevent tailing, as well as smudging when the inks or dyes are being separated. Chromatography is the technique used to separate small amounts of substances from a mixture based on the different solubilities of the components in a particular solvent. Now pause the video and think about what are some of the advantages of using chromatography over the other separation techniques you have learned. The principal advantage of using chromatography is that only a very small sample is required for the analysis. To begin, we first add a small amount of a suitable solvent to the beaker. In this case, why do you think water is a suitable solvent? The choice of solvent depends on the type of sample we are using. In this case, as we are using water-based inks, water is a suitable solvent because the inks are soluble in water. Moving on, we now place the chromatography paper and immerse it in the solvent. We also must not forget that we have to cover the beaker with a lid. Why do you think this step is important? Covering the beaker with a lid minimizes evaporation of the solvent as it travels up the chromatography paper. You can see that as the solvent moves up the chromatography paper, it carries the different dyes along with it. Dyes which are more soluble in the solvent will migrate faster and further along the chromatography paper. Here we see the solvent front moving upwards. When the solvent front has reached near the top, we then remove the chromatogram and mark the solvent front with a pencil line. Why do you think this step is important? The applied spots will be traveling up the chromatogram relative to the measured solvent front. Knowing the solvent front is important for the calculation of RF values.
And that's where we'll stop watching, because you don't have to learn about RF values in grade 7 just yet. But I did want you to see the difference between all those colors, because if you remember, you had all the different colored dots on the bottom, and as the water was traveling through the paper, It was dragging along different color pigments at different speeds. Like the guy said in the experiment, the lighter the pigments, the easier it was for them to travel up. So that's why you saw some colors were traveling higher and some were staying at the bottom. And that is chromatography. So you are elaborating on what you've just learned as well as what I am about to share with you. We are going to design an experiment that shows the best ways to separate mixtures. And if you remember, when you design an experiment, you have an objective, hypothesis, materials, methods, observation, and conclusions. So you have a section for each of these headings. And an objective specifically is the reason why you're conducting this experiment. What is the point? That is what your objective is. You write a couple of sentences to say, this is why I want to conduct this experiment. The hypothesis is what you think will happen. So once you've conducted the experiment, you will have such and such a result. And that is the prediction that you make during your hypothesis. The materials is kind of like the ingredients you need to make a meal or to bake a cake. Similarly, when you design an experiment, you need to have a list of all the different things, whether they be tools or materials, that you'll need to conduct your experiment. And then obviously you have to have step-by-step instructions of how to do it, so that not only can you do your experiment, but someone else can do it too. Then once you conduct your experiment, you are going to observe what happens. You're going to write everything down that you see. And once you've done that, you're going to draw conclusions about what you learned. So you're going to think, these are the things that happened in the experiment, and this is what I now know because I conducted this experiment that I didn't know before. So those are all the different parts of designing an experiment. And what I want you to do today is I want you to look at page 89 of your textbook. And there you'll answer question 1, 2, 3, and 4, which will be the clues that you will need to design an experiment of your own. So I want you to design an experiment that shows the best ways to separate the mixtures that they've asked you for in your book on page 89. You're going to write the objective of the experiment. You're going to write what your hypothesis is, what you think will happen. You're going to write the list of materials as well as the list of steps that you need to take, the method of your experiment. If you want to carry out your experiment, you can, but it's not a requirement. You just need to go up to that step of writing down the method. Once you've done that, you know you should press play to continue with the lesson. Well, guys, you did it. Congratulations. Today you did so much. You discovered what your favorite drinks are. Well, more like you discovered that your favorite drinks are actually mixtures. You identified different types of mixtures, whether it be a solid and a solid or a solid and a liquid. You learned about 7 different ways in which to separate those mixtures. And not only did you learn all these things, but you also applied what you learned. You answered questions from your textbook and you designed an experiment. Congratulations. That's fantastic work. Give yourselves a big thumbs up. Well, now I want to know from you. How did you find this lesson? Was it interesting and challenging? Just right? Too hard? Or way too easy? Think about it for a second. Okay, well, before you go, I have one more thing for you to do. And what it is I want you to pretend that a friend of yours never got this lesson. So you have to send them a voice note to explain to them what you learned. So I want you to pause the video, write down what you would say in the voice note, or you could actually record a voice note. And then once you've done that, I want you to play the video to continue with the lesson. So, you have just written down the script for a voice note, or you have actually recorded a voice note. But there's one more thing that you could do. However, since this is the end of the lesson, I am giving you the choice. You can either decide to continue and do this activity, or you can decide, I've done my fair share for the day and I am going to end the video here. So, if you do decide to end the video here, maybe just skip a little bit to the end so I can say goodbye to you. But if you do decide that you want to do the choice activity, here are the instructions. You are going to create a mind map. I just love mind maps because it takes all the information that you've just learned about and puts it onto one page. One page that's easy to find and easy to remember. So basically what you want to do is you want to create a mind map of the 7 different ways in which you can separate mixtures. I want you to have each of the different ways written in big words, and then with each word, so whether that's evaporation or distillation or filtration, I want you to give a brief description about what that method of separation is. And this is where it comes in handy, those sentences you wrote earlier in the day, because now you can use those sentences and just plug them in here. And then finally, I want you to choose 1 or 2, even 3 examples of different kinds of mixtures that you would use those methods of separation for. So for example, next to evaporation, you could put salt water. Next to sieving, you could put soil. Next to filtration, you could put a gas mask for a fireman. Next to hand sorting, you could put, well, you know the answer to that. So you can use whatever examples you want, but I want you to put examples for all 7 different types. And then that's it. You've created a mind map that will help you remember what you learned today. Congratulations. So thank you so much for joining me today. I'm so glad that I got to learn with you and discover with you and just have a great time. I hope that you had a good time, and I really look forward to teaching you and learning with you tomorrow. Bye bye now.